Hello, and welcome to a training session on using StatWizard's Experimental Design Wizard. My name is George Boomer. Join me for the next hour while we explore the world of experimental designs for discrete choice models and how you can use the design wizard to create them. During the course hour, we'll cover the following topics. We'll start by discussing briefly what discrete choice models are and why they're valuable to marketers. Then we'll provide an equally brief introduction to the theory and practice of experimental designs and share with you the idea behind the design wizard. We'll then move on to an online session where we will build a simple design using the design wizard. Next, we'll show you how to extend designs using Excel's capabilities. Finally, we'll pull out all the stops and show you a real-world example of the kinds of designs you can build using the experimental design wizard. Let's talk a bit about discrete choice models. Why are discrete choice models becoming widespread? Because they can help weigh the importance of features, prices, and other product attributes on consumer choice, and they can serve as engines for market simulators that can help project the success of new products in a competitive marketplace. What's the theory underlying discrete choice models? Reduced to its essentials, it's that all transactions involve choice, and the choice consists of two components: a systematic component involving rational, observable comparison of product attributes, and an unobservable or random component consisting of an amalgam of things such as impulse buys, irrational or psychological elements, and so forth. Discrete choice techniques model the systematic component and assume the unobservable component follows a specific distribution. Why is modeling the systematic component important? The answer is that it can tell you what combination of features and pricing have the most appeal to potential customers. There are basically two types of discrete choice models: those measuring revealed preference and those measuring stated preference. With revealed preference models, we observe how people make choices in the real world. In other words, we look at the choices they've already made. We gather historical data on these choices, often in conjunction with information on the people who made them. Then we build models based on the results. Stated preference models help in situations that either don't exist or are hard to measure. In stated preference exercises, we construct hypothetical choices and ask people to select among them. And we can do so in a variety of ways. We can ask them which item they prefer. We can also ask for their least preferred option, or we can ask for full or partial rankings. We can also mix and match stated preference and revealed preference models. We can estimate stated preference models, then calibrate them to actual scenarios in the real world, or we can estimate stated preference off revealed preference models, sometimes called SP off RP, in which we start from choices that subjects have already made and ask them to choose among alternatives that would induce them to switch. Kenneth Train from UC Berkeley has developed estimation routines for this latter category. Both stated preference and revealed preference models have their strengths and weaknesses. With stated preference models, you work in an experimental setting and can therefore get more information than is available in a real marketplace. By contrast, with revealed preference models, your study is limited to the choices subjects have already made, and not all subjects may be familiar with the complete range of options available to them. With stated preference models, you can control for interactions among attributes, whereas in the real world, attributes are often highly correlated. For example, car manufacturers may want to study the utility that consumers place on trunk space versus wheelbase. The problem is that cars with longer wheelbases have more room for large trunks, so in the real world, the two attributes are highly correlated. However, in a hypothetical experimental setting, we can eliminate that constraint by including, for example, combinations of large trunk space with short wheelbase. Other differences concerning relevance apply, but you can read those from the slide. The key point is that stated preference research always requires an experimental design. Bearing that last remark in mind, we now move on to a brief discussion of experimental designs. Most market research studies involve stated preference exercises and therefore require experimental designs. These designs generate sets of hypothetical products based on the attributes and levels the researcher selects. They're organized into choice sets, or hypothetical store visits, in which we ask respondents to choose among a set of alternatives. To make the exercises more realistic, We often give respondents the option of choosing none of these, or I will buy later, or other appropriate alternative. Let's talk for a moment about the steps required to generate an experimental design. The process looks like this. First, break the product or service into a set of attributes and levels. Attributes are product characteristics, such as form factor, color, brand, price, message, and so forth. Levels are values that an attribute can take on. For example, a brand attribute could take on the levels Sony, Google, Apple, and so forth. The next step is to choose an appropriate vehicle for generating your design. If you're familiar with design theory, you can use tables, or you can hire an expert, or you can use software, which we're covering today. Once you have chosen your method, you enter an iterative process in which you construct your design, evaluate the results, then begin the cycle again until you're content with the design. In our experience, designs go through a minimum of 4 to 5 iterations before they head to the field. Probably the most critical step in the prior list was the first, developing an attribute list. This sounds simple, but it's marked by potential subtleties and pitfalls. Some guidelines we recommend are: define the marketplace not from the point of view of the supplier, but from the point of view of the customer. If you're conducting a study of tablets, for example, you should consider including all products that consumers might view as substitutes. For tablets, that would mean smartphones and laptops as well as other tablets. Focus groups can provide information on what consumers include in their consideration sets. Ensure attributes are independent. Design methodology strives to eliminate correlations among attributes and levels. You can help by excluding correlated attributes from the very beginning. For levels, use precise, concrete statements with metrics if possible. Avoid ambiguous terms or those that can be easily misinterpreted. This is good advice for questionnaires in general, but it's particularly true here. Levels within each attribute should be mutually exclusive and collectively exhaustive, sometimes abbreviated as MECE. We want all elements of our design to be as uncorrelated as possible. Levels should contain ranges sufficiently extreme to cover the shelf life of the research. This is particularly true of price, especially in technology markets where dramatic price changes are the norm. If you intend your research will have a shelf life of more than 2 years, include a range of prices that will encompass that time period. Avoid what some companies call table stakes or antes. These are attributes that all suppliers must have to compete in the marketplace. A few years ago, for example, cameras began to appear on mobile phones. So much discrete choice research into mobile phones at that time included camera-related attributes. Now, however, virtually all mobile phones have cameras, so including them as attributes in a contemporary study would waste survey resources. Throughout this and other exercises, we'll use a simple shoe example. Our example includes 3 attributes: fashion, quality, and price. Each of these attributes has 2 levels. For fashion, we have traditional and modern. For quality, standard and high. And for price, $25 and $149. Because we have 3 attributes with 2 levels, we call this a 2 to the 3 problem. What does an experimental design try to do? It tries to satisfy a number of objectives. In constructing store visits, we want to avoid any correlations that exist among products or between stores. We've already talked about this. Ensure that each level appears an equal number of times so the appearances are balanced throughout the design, and minimize the number of times a level appears in a given store. This helps coax as much information as possible from each store visit. One thing the mathematics of experimental design do not do, but what we would like, is to ensure our choice sets mirror what respondents might see or experience in the real world. The closer we can mimic the actual choice process, the narrower the gap between pretend tasks and actual behavior. We can't always satisfy all these objectives, so we must occasionally be willing to compromise. Design theory helps us make these compromises, and placing guidelines in software can push us further. Design theory contains some common terms that you might encounter. There are mathematical descriptions for each of these terms, but we won't go into them here. We talked about the desire to avoid correlations among design elements. Absence of correlation is called orthogonality. We also talked about the desire to have levels appear an equal number of times throughout the design. This is called balance. Orthogonality and balance are combined in various ways to produce measures of design efficiency. These measures, one of which is d-efficiency, are usually converted to a 0 to 100 scale, in which 100 represents perfect efficiency. All Design Wizard designs start at d-efficiencies of 100. Overlap measures how often levels appear multiple times in a single store, and resolution indicates the degree to which a design permits variable interactions to be estimated. The higher the resolution, the more interactions are permitted. With that as a background, we now move on to talk about the reasons the Design Wizard came into being. Why did we make the choices we did in creating the Design Wizard? After spending over 20 plus years in consulting, we noticed that not 90%, not 95%, but 100% of client data sets arrive either in Excel or in SPSS, which can be easily converted to Excel workbooks. It seemed clear that Excel was the only platform to use for development. We also wanted to let the user start in the simplest way possible with a list of attributes and levels in a blank spreadsheet. We wanted to help new users every step of the way, but not slow down experienced users. At no point did we want to abandon users to blank, empty fields. Rather, we wanted to insert best practices as defaults at all decision points. We wanted to provide output that was camera ready, web ready, or easily manipulated by survey programmers so that a minimum amount of extra work was needed. We wanted to make execution as fast as possible, assuming that our users' time was valuable and scarce. We wanted to interface with all major estimation programs as you see in this list. We wanted tight integration with other StatWizard's modules, which we'll cover in other training sessions, and we wanted to set the price, in this case $800, so that payback was immediate. Now we'll proceed to take you through a simple exercise using our shoe example. Let's start by typing in a list of attributes and levels for our hypothetical shoe example. As you recall, we've got three attributes: fashion, quality, and price. Under fashion, we've got two levels: traditional and modern. For quality, we've got two levels: standard and high. And we have two price levels we're going to change a little bit. One is $25, and the second's $125. Okay, let's just neaten the columns up a little bit. Now what we do is to invoke the Experimental Design Wizard. We do that by going to the Add-ins tab if you're using Excel 2007 or higher, and clicking on the appropriate button. And if you've got your cursor initially anywhere in the list, the wizard will select the entire list. It also allows you to edit the selection if you wish, but we don't have to do that at this point. And then it asks you if you want to add summary data. So let's go ahead and do that. And then it provides some information to us where it says we'll be returned to the spreadsheet and to review all the new lines that it has added. Let's zoom the view a little bit to make things a little easier to see. What you'll notice here is that the wizard has guessed the number of levels to each, because that's what we entered. But let's go ahead and change our price levels from 2 to 5. Also, the wizard has allocated types to each one of our attributes. A fixed type applies only to the very first attribute. That is very helpful in cases where For example, you might have brand as your first attribute. Fixed types are such that each store visit contains exactly the levels that appear in this list in the same order. Now, that's not necessary here, so let's go ahead and change the type to categories. Also, you'll notice that the wizard has guessed that the price has a continuous type. The wizard also constructs variable names from the attributes. In this case, it's fairly straightforward because all of the attribute names conform to the 8-character limits imposed by many estimation programs. The wizard also, by default, says that we want to include none as part of the attribute set. And then it makes some suggestions for us. It selects 4 choices per store and 1 block. You're perfectly free to override either one of these things, but in this case it's not necessary. Let's go ahead and rerun the wizard. Now we could go back to our add-ins tab here, or as a shortcut we can press Control-Shift-E. So let's just go ahead and do that. The wizard proceeds to validate the attribute list that we have just entered, and you'll see here that for price it notices that we specified 5 levels but only entered 2. Would you like me to fill in the remaining levels? And let's say yes. So with that we have a successful validation. If I move this a little bit, you'll see that price now has the requested 5 levels. So we'll go ahead and build a design. What I'm going to do now is just go through and show you just how quickly we can create a design. There we've done so. So that's all the time it takes to build a design using the design wizard. This is store 1. By clicking other store numbers in this box, you'll see the other stores appear. You'll notice that over here in column H we have a number of items that we can change. By default, there are no circles that appear at the top of each of the choices. The reason for that is that the default case is that we would like to print out all of these stores and have respondents manually fill them out by circling the number corresponding to choices. However, if you happen to have software like Remarks OMR that can collect mark sense responses, you can click on yes to the circles, and circles that are exactly the right size for Remark OMR to sense will appear on your stores. Then if you want to construct web choices, you click on web underneath circles and the appropriate language appears. Now if you want to set up a max diff design, you would change max diff from no to yes, and you'll see that a second row of circles either for the web or for OMR or none at all will appear. That would allow you to collect max diff responses. If you click on the Print All Stores button, by default all the stores get printed to sheets, as you can see down here. These are very useful for copying and pasting into web pages so that you can collect the results. And they can also be integrated directly into certain web programs. Now if you want to rotate the choices, for example, you might want to prevent straight lining, you can click on yes to rotate choices, and then when you move from one store to the next, you'll notice that the choice numbers themselves change. So store 3, store 4, store 5. Okay, let's set rotate choices to no, and that ends our example. Now that we've shown you how the design wizard can help you quickly construct a design, we'll show you how the power of Excel can help you stretch your design in useful ways. Let's say that we'd like to conduct our survey in Europe as well as the United States. So we'd like to express price in terms of euros in addition to dollars. There's a very easy way to do that in Excel. First, let me show you a little feature that facilitates that. This is a feature that was added by the design wizard. Over in column A, if you change any of the numbers here, let's say we swap 1 and 2 with 2 and 1, that will change the position of those 2 attributes in our store layout. Right now, as you can see, fashion is first, quality is second. If we change these two numbers from 1 to 2 to 2 and 1, you see that now quality is first and fashion is second. That's a feature we are going to use in just a moment. First, let's put our numbers back. Now let's go to the Design tab. Here's where our design resides. This is the source information that went into producing the layout. You can see that there's a column for price. Well, right next to that, we're going to add a column for euros. So let's simply call this euro price. And let's give it a variable name of EUR price. That's 8 characters or less. Now, just to help things out, we'll add a place for the exchange rate. Let's say that the exchange rate is 0.71 euros per dollar. We'll label the cell. And to make things a little easier, we will create a range name for the exchange rate. The next thing we do is to place a formula for the amount underneath our new variable name. So the basic formula is this. It's simply going to be the price in dollars times the exchange rate. We can go a little bit further than that and say, let's do two things. We're going to change the formatting so that it's no longer dollars, but it's euros, and we're going to reduce the number of decimal places. So let's go find euros. There we go. And let's say we want to get fancy. Let's say that we want to round our values of euros to the nearest 5 euros. Well, it turns out Excel's got a function for that. It's called mround. There's in round. We want to round it to the nearest 5 euros. So there's our price in euros rounded to the nearest 5. We copy that to all the remaining rows in the design table. And now we're ready to go back and recreate our layout. The way we do that is to click on Generate Experimental Design. We go back one step. We recreate the layout. And here we have prices in both dollars and euros. Now, of course, we don't want both to appear in the same questionnaire. So we can simply eliminate, in this case, the dollar price. We make sure that there's nothing to the right that will be affected. In this case, it's not. So we simply delete this row. And now we have the price in euros. If we wanted to change back to dollars, we would change the value in cell A9 from 4 to 3. These are prices in dollars. All we need to do is to go back and change the formatting back to dollars. And here we are. So you can see that very quickly we have added the ability to express prices in more than one currency. That's something that's very difficult to do in any other design program. The next feature we'd like to show you is a new exciting one. It's called automatic language translation. Let's say that we want to take this survey and show it to people in 6 different countries in the world. How do we take care of language translation? Well, it turns out with the Design Wizard it's pretty easy. All you have to do is click on the Translations tab here and follow the directions at the top of the page. The first thing it asks is to update the exchange rates if necessary. So let's go do that. Let's change the exchange rate to 0.73. Next, the instructions say to click the button on the right for gathering all the English words in our design, so let's do that. And you'll notice that at the bottom of the page, we now have all of the English phrases in our design sorted in a table that you see here. So how do we get translations for all of these phrases? Well, there's a great website called Online Document Translator, And there's a hyperlink for that conveniently placed in the translation sheet. So let's click on that. And as you can see, we now have opened the document translator. I'm going to resize it a little bit. And one of the elements here is translation from Excel in English to Excel in other languages. So let's just select that. The wizard has automatically placed an English submission file in our documents folder. So that's going to be used as the source for our translations. The site has picked English as the default language, so let's go translate that into some other languages. Let's start with French. We click on the arrow button in the center, and you can see that almost instantaneously a new file was created with the appendages EN and FR, signifying that we translated from English into French. So let's save that file. Let's go and get our English submission file again. This time we'll pick German. Click on the center button and there's our German file. We'll save that in the same place. Again, we'll get our English submission file. This time we'll pick Portuguese. Oh, let's pick Italian. There's Italian, so we click on the center button. There's our translation file from English to Italian. We save that file. We repeat the process again. This time we'll pick Portuguese. There it is. Click on the center arrow. There's our file. We'll save it. And we'll repeat the process one last time, this time for Spanish. There's Spanish. Click on the arrow, and now we have all of our files. We can close the website for now, and then we follow the remaining instructions that you see here. What we're going to do is to take those files that we just created. So let's go get all of them. There we are. There's German through Portuguese. Open them up. There they all are. This one happens to be Portuguese. Let's copy that file. Go back to our original book. Paste it in the column labeled Portuguese. We'll do the same for the other files. There's Italian. So we'll copy that. Paste that into the Italian column. Next, let's get French. Copy that. That'll go into the French column. We'll get Spanish next. We'll copy that. Place that in the last column. Then the one remaining file is German. So we'll get that, copy it, and place that in the German column. So now we have our phrases translated into all these languages. Incidentally, you're not restricted to these languages at all. You can use any mixture of languages as long as it's handled by Google Translate. Google is the engine that is used to do the actual translations. Now, let's go back to our layout sheet, and what we'll notice is that we've got a brand new selection item here, and this one is language. So we start with English. Let's see what happens when we click on French. By straightening the columns up a little bit, what you'll see is that our entire design has now been translated into French. So here you can see as we go through all 5 stores, and not only is the translation made to French, but also all the prices have been converted to euros and the appropriate symbol has been used. So that was French. Let's take a look at German. So there's our design translated into German. Again, we might have to neaten things up a little bit. There we go. German, we have Spanish, Portuguese, and Italian. So what you can see is that with relatively little effort, we've translated our entire design into 6 different languages. So this is the automatic translation feature. Now we pull out all the stops and show you just what the Design Wizard combined with Excel can do with a complex real-world problem. The engagement at hand is a recent syndicated study of broadband quad plays, which combine digital TV, internet, telephone, and wireless services under one contract. The study was conducted on behalf of Strategy Analytics, an international consulting firm that offers a variety of syndicated services. This is the actual design used for the quad play study. The study's objective was to propose a set of bundles to customers with existing contracts to see what might induce them to switch from their current plans. In that sense, it was an SP off RP study. Under Plan, we see the offered bundles: TV, Internet, fixed phone, wireless. These are the 4 components of quad play. You'll also notice that below them are all realistic combinations of these components. Notice that in the place of actual prices, we substituted codes that are sent to lookup tables that we'll cover later. Brand also uses a series of codes in place of specific levels. The reason for this is that the study was conducted in multiple countries in the US and Europe, so we wanted to use brands and pricing that reflected market conditions in each country. Each quad play component had its own set of attributes and levels. To make things easier, we color-coded attributes for each component. For digital TV in magenta, we had basic channels, premium and entertainment channels, premium sports packages, and options. For the internet, we had access speed, data throughput, and customer and technical support. For phone, we had 2 attributes: voice plan and estimated minutes of use each month. And then the wireless component contained the remaining attributes. Let's go to the lookup table to see just exactly how complicated this design was. Here you see the table that we used to select prices and brands for each country. Prices were built up from service prices, each of which could take on a maximum and minimum value. We do the same thing for the components. For brand, we have yet another table that you see here. Brand levels are in rows by country, and brands associated with potential bundles appear in columns, as you see here. Unique brand names are color-coded blue. Let's now see what the layout looks like. The challenge we faced in constructing the layout sheet was presenting the large number of attributes and levels to subjects without confusing them. We did so by using the color coding scheme we saw on the attribute sheet. Colors for component names match their associated attributes. You can see this as we cycle through stores: store 1, store 2, store 3, and notice that in each bundle where we have a component, for example, we have internet in bundle 3, there's a color-coded set of attributes and levels that appear for that component. Also, notice that we incorporated automatic language translation and currency in this design. As we select various countries, from the US, France, Germany, Italy, Spain, and the UK, Languages, brands, prices, and currencies adjust. That shows you what you can do using the Design Wizard with Excel. It's difficult to imagine that what you have seen could be done by any other program. In summary, we gave you a brief introduction to experimental designs, showing how they attempt to extract as much information as possible from stated preference studies. We then showed how the Design Wizard helps analysts construct experimental designs quickly and efficiently, in minutes rather than hours or days, and how those designs meet criteria for efficiency. Finally, we demonstrated how basing designs in Excel lets you extend designs to meet complicated real-world needs. That's the presentation for today. Here's a list of web-based resources that you might find useful if you would like to pursue this topic further. Thank you very much.